Okay, so we're going to end the skeletal system lecture by talking about bone repair. And so we've got three different outcomes for this one. And so we're going to start by talking about the different types of growth. So we've got interstitial growth, which is where the bone increases in length. Okay, this is the one that like my kids want to have happen right now, right? So we just measured all of my kids on Sunday, how tall they are, how much they weigh. My youngest son, who's like 4'2", keeps wondering when he's going to grow and be taller than his brother and his sister and me and, everybody. And, so he's eating lots and lots of food because he's convinced that if I eat lots and lots of food, I'm going to get tall. That'll help, but obviously it's not quite the only thing. Okay. And so this only occurs at the epiphyseal plate. All right. And so, but in order for this to happen, we have to have what's called hyaline cartilage. And as long as that hyaline cartilage is present, then we're going to increase in length. But as you're probably aware, when the epiphyseal plate closes, then the growth, so getting taller, ends here, right? So we've got the epiphyseal plate, which is here, all right? And so what happens is that cartilage is released by bone, but as long as we've still got some cartilage there, then we will be able to have this interstitial growth. This is something that stops in women generally when they're around 18 and men when they're around 21. And this really breaks my daughter's heart because she's about 1/8 of an inch shorter than than her mom. And so she might be the shortest one in the family when all is said and done, even though right now I guess she's not the tallest, but she's, she's the oldest kid. Then we've got appositional growth. And this is where the bone itself gets basically fatter or wider, increases in diameter. Okay, so this occurs in the I can't talk today. It occurs inside the cell. All right. So this occurs all throughout life. And basically what happens is osteoclasts absorb or resorb that old bone that's in the medullary cavity. Okay. And so you've got these osteoclasts that resorb that bone while the osteoblasts produce new bone tissue. So the erosion of old bone along the medullary cavity and then the deposit of new bone beneath the periosteum, that's what causes our bone to get wider or have this appositional growth. Okay, we can see that here. All right, so fracture repair. So I have never broken a bone that I'm aware of. Actually, there's a couple of times I think I have, but I've never got it x-rayed or anything like that. But this is what we're talking about. So most of you have probably broken a bone before. So we've got two types of fracture repair. So we've got direct and indirect. So direct is where new bone is formed where the fracture occurs. Indirect is where we've got kind of some endochondral bone formation. All right, so we're going to go through how this works here. So I've got this nifty little graphic to show us. And so with fracture repair, there are four main steps. So you've got the formation of a hematoma, you've got the generation of new bone, you've got the formation of what we call a bony callus, and then you've got bone remodeling. Okay, so let's take each of these individually. So with the hematoma, blood vessels in the broken bone tear and hemorrhage. And so this results in the formation of blood clot, which is also known, I guess more correctly, as a hematoma. So the blood vessels that are severed at the broken ends of the bone are sealed off by the clotting process. So that's good because we're not losing any blood. However, this causes bone cells to not have access to nutrients, and so some of the bone cells die. So we need to kind of fix the gap there. We need to replace these dead bone cells. Okay, so within days, capillaries grow into the hematoma while what are called phagocytic cells clear away the dead cells. So we get rid of the dead cells, we bring in capillaries so we can bring in nutrients. And so ultimately what happens is we get osteoblasts in the area and they begin to reform that bone. Okay, we get collagen fibers formed that connect the ends of the broken bone. All right, and this starts to form something called spongy bone. And this repair tissue between the broken bone ends and is composed of hyaline and fibrocartilage. And so that's what's going on here. So basically, capillaries come in, we get rid of the dead cells, we bring in osteoblasts, which form new cells, and then we've got these collagen fibers that start to form that connect the broken bones together, or the broken ends of the bone together. So then we've got this bony callus formation. And so this cartilage callus is converted into a callus made up of bone, and it might take up a couple months for this to be firmly joined together. Okay, and so again, this is similar to the endochondral formation of bone when cartilage becomes ossified or calcified. And so at this point, we have osteoblasts, osteoclasts, and that matrix present. And then finally, we've got bone remodeling. And so this callus is remodeled or reshaped or reformed, or however you want to look at it, by osteoclasts and osteoblasts. Okay, and wherever we've got excess material, that's removed. And so compact bone is added to create bone tissue that is similar to the original unbroken bone. And this remodeling and removal of old tissue and stuff, this can take a long time. It can take months or even years. Okay, and so we've got the formation of the hematoma. We get these the new blood supply in there. We get that bony callus, and then we get the bone remodeling. So, with the end of the skeletal system, and specifically this lecture, are you able to do these two things?